In this workshop, we're going to continue doing some pressure versus composition diagrams. We're going to use the same system we used in the previous workshop, which is at vapor-liquid conditions. Now, of course, pressure will be changing. It will not be 1 atmosphere. And now we need to fix a temperature. In this case, I chose 25 Celsius, even though you can choose whatever temperature you want. Same compositions. But from the previous workshop, remember that we need to state the 4 components, then choose both methods, ideal and unifac, then go to binary. In this specific case, I'm going to override them. So instead of running this, I'm going to choose the PXY diagram. On the same ethane pentane mixture, all remains the same, and the temperature it is set by default by 225 Celsius. So if I wanted to model this at 50 Celsius, I could, but let's leave it on 25. Let's run the analysis. And well, we got this diagram, which is the ideal one. Vapor liquid mixture for the liquid should be, let's say, constant with slope, because the liquid won't change lower with exponential, similar to this one. Now let's compare the real one. Ethane and pentane with unifac, PXY diagram, run analysis. And as you can see, with this model, we do have a slightly different interaction with the liquids. They are not assumed to be ideal, as well as the vapor. So let's note that actually here the envelope does have vapor liquid, but at high pressures we have liquids, and at low pressures we will have vapors. Now it's inverted compared to the temperature one. Let's merge this plot to number 1, and now we will see that it actually deviates strongly. Let me use the same axis. Yeah. So the vapor line is pretty good fitted, maybe slightly differences, but the main difference here is that we are considering the interaction between pentane and ethane, whereas the ideal one will not consider that interaction. So we have this little phase change. Now let's do a real solution. PXY diagram for water, phenol, still water. Temperature will be 25 Celsius and vapor liquid phases are valid. Let's run. And we get this. Very similar to the previous one. Let me run the analysis for the same system using unifac, still water, vapor liquid, and 25 Celsius. So clearly we have a different interaction compared with the ideal model. Let's merge the plots. Single axis. Now, as stated before, maybe the vapor line is pretty similar. You don't see that much of deviation, but in the liquid phase we do have a strong deviation. The red line is the real line, or the unifac model, and the blue one is the ideal model, a straight line with constant slope. So once again we have this difference in the interactions. So clearly we should model this with the real model as the ideal model. So that's up to you. If you stay with the ideal model, just ensure that you will have differences on your vapor liquid equilibrium data.